oxide can conduct the iron through the polymer chains. So they implemented this polymer electrolytes into the systems like energy storage systems, which is in this case battery. So they found that it works. So let's talk about what types of polymer electrolytes we have. So we have three types of polymer electrolytes. First of all, we have liquid electrolytes, polymer electrolytes. Actually, these differences according to the role of the polymer matrix in the system. So in liquid electrolytes, our polymer acts as a component in the system. So it's just increase the conductivity of iron, and also it increase the stability of the electrolyte. So for the gel polymer electrolytes, our polymer matrix acts as a medium host material. So we have salts, which is in this case lithium perchlorate, and also we have some solvents like organic solvent, ethylene carbonate, or some kind of organic solvents. And inside of the polymer matrix, we have these liquid electrolytes. So in here, our polymer increase the mechanical property and also increase the ionic conduction. So for the solid polymer electrolytes, our polymer acts as a host material and also as a solvent. So in here we don't have any liquid electrolyte, we have just salt inside of the polymer. So our polymer acts as a solvent, so it dissolves, and also it is a medium, it's a host material for the electrolyte. So because of this property, we don't have any liquid, so we don't have safety issues, some kind of flammability or kind of things. So let's move on to the other page. So as I said, in 1970s, the research started with polyethylene oxide because of the excellent solvation property of polyethylene oxide, and also the mechanism of ionic conduction in polyethylene oxide. It is so obvious, and also it's much appropriate for ionic conduction. So which I will explain later. So why we choose solid polymer electrolytes? Why the engineers and people in this area say that our future solid polymer electrolytes? Because of the high energy density we can get from the solid polymer electrolytes, the flexible design options, so we can produce thin film electrolytes. So we have lots of battery architecture by using that. So also, as I said, safety benefits. We don't have any liquid, and so we have low reactivity. So we don't have any liquid leakage. So it's so safe compared to the other ones. So also, because of the property of solid polymer electrolytes, we have high thermally and electrochemically stable window. So even if at the high temperatures, our battery can work well, and also electrochemically, what I mean, we can apply high voltage, and it can resist this. It can handle this voltage. And also environmental and cost advantage of polymer electrolytes. They have solid polymer electrolytes, PO. They have low volatility, so it reduces the flammability risks in the normally daily usage. So lastly, I'm gonna talk to you about the ionic conduction mechanism on solid polymer electrolytes, specifically polyethylene oxide. So as you can see, in polymer electrolytes, we have some reagents, amorphous reagents, and also crystallization reagents. So ionic conduction occurs on the amorphous region, because in amorphous region, our polymer chains can move freely. So what is the steps of the ionic conduction? First of all, dissociation of lithium salts. So first of all, in the polymer, in the polymer matrix, our solid polymer electrolytes, which is in this case polyethylene oxides, solve the salts. Then our lithium ion in this case interact with the polar group of polyethylene oxide. These yellow ones are oxygen in here. So our oxygens and lithiums can interact in here, and then they make a coordination region. So in amorphous region, as I said, they can move freely. So if we apply an electric current, our lithium ions can hopping from one chain to another. So we call this mechanism ionic hopping mechanism. So this is the generally this is the ionic conduction mechanism of solid polymer electrolytes. In every polymer electrolyte types we have similar but different types of ionic conduction mechanism. Scientists prefer these polyethylene oxide because of this excellent conduction mechanism. Here